So this numerical was asked in the year January 2019. And as I said to you that from COD, one numerical will be a definite question for 6 marks. Okay, so write down the question. In a COD test, in a COD test, 30.2 cm cube and 14.5 cm cube of 0.059 N of FAS solutions are required for a blank and sample titration respectively. In a COD test, 30.2 cm cube and 14.5 cm cube of 0.05 normal FAS solutions are required for a blank and sample titration respectively. The volume of the test sample used was 25 cm cube. Calculate the COD of the sample solution. So as we know that COD can be calculated using the formula B minus A into normality of FAS into 8 into 1000 divided by V. So we saw it in the yesterday's class. So what is B? B is the burette reading of blank titration. That is volume of the FAS required during the blank titration. And A is the volume of FAS solution required during the back titration. And which burette reading will be higher? Blank will be higher or back will be higher? Yes, you substitute. And 8 is the equivalent weight of oxygen, because as I said you, for BOD and COD we are measuring the values based on the oxygen demand, because it is the amount of the oxygen required for oxidizing the organic matter, right? So 8 is the equivalent weight of oxygen and 1000 because the answer is in terms of mg per liter. So substitute the values and let me know if you have got 251.2 mg per liter. And do remember that as it is just a two-step calculation and the marks are for 6 marks, so you have to write all these given in detail. It will be better so that it will look little bit lengthy, right? So you can write like volume of FAS required during the blank titration is equal to so much, volume of FAS required during the back titration is equal to so much, volume of the samples taken is so much, and normality of FAS is so much. So in detail, if you write the given things, it will be better because the marks carrying are 6. So did everyone get 251.2 mg per liter? Yes. Are you getting?
Yes, ma'am.
Hmm. So all the numericals which I am solving are the exam appeared questions. Okay. Take down the next numerical. This was asked in July 2018. It is the same type as that of the previous one which we solved now. So here in a COD test, 32.7 cm cube and 23.5 cm cube of 0.02 NFA solution are required for blank and sample titration respectively. Sample titration is nothing but back titration only. Okay, and the volume of the test solution taken is 25 cm cube. Calculate the COD of the solution. Substitute the values and let me know the answer. Please unmute and answer, okay? Because otherwise I have to go to the chat box and see again to the other screen. I'll not go there. You answer me here only by unmuting yourself. Yes, how much you got?
On 65.28.
ಎಷ್ಟು?
Okay. I got 60.
58.88.
58.88 ಬರಬೇಕು.
Yes, one check.
Huh. All of you check whether you got 58.88 mg per liter.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Those who didn't get, just cross check it. So this is higher butyrate reading, that is blank, and this is lower butyrate reading, that is for back. Back is nothing but sample titration and normality of FAS into equivalent weight of oxygen in 2000 divided by volume of the sample taken is 25. So check the answer. It should be 58.88 mg per liter. Okay, next one. So here, take down 20 ml of a sample of water for COD analysis was reacted with 15 ml of potassium dichromate. So here in detail they are telling the entire procedure. How much volume of sample was taken, how much potassium dichromate was added, and the unreacted dichromate was titrated with FAS. At that time, what was the butyrate reading observed and what was the concentration of FAS taken? So for back, how it was done, for the blank titration using distilled water, how it was done. So there are so much data, but we need to pick only the data that we need. That is, we need concentration of FAS, volume of FAS, that is the butyrate reading for both the blank titration and the back titration, and the volume of the sample taken. Okay, so here 20 ml of the sample of the water. So this is V. 20 ml of the sample of the water, that is the volume of the sample taken is V. It is 20 ml. For COD analysis was reacted with 15 ml of potassium dichromate. And then the unreacted dichromate required 22 ml of 0.19 FAS for the reaction. So we need this data now. 22 ml of the FAS was required for back titration. This is back titration. So butyrate reading for back titration was 22 ml. So this is A. And normality of FAS is 0.1 for this reaction. Okay, under similar conditions, 15 ml of potassium dichromate mixed with 20 ml of distilled water required 38 ml of 0.19 FAS. So now 15 ml of potassium dichromate was taken. Along with that 20 ml of distilled water was taken and the reaction was carried out. And later, after the refluxing for 2 hours, the sample was taken and it was titrated against FAS. So the butyrate reading observed for distilled water, that is for blank titration, was 38 ml. And the concentration, again FAS, we are taking the same concentration. So it is 0.1. What is the COD of the sample? So you have to write in detail like this I said, right? Okay. Volume of sample taken, volume of FAS required for back titration, for blank titration, and then normality of FAS. So substitute the values. Formula is same. Just a simple direct substitution. Only thing is you need to understand what data is for butyrate reading, for back titration and for blank titration in these kind of numericals. How much you got? Answer, students.
1 is it
640.
640?
640?
Yes,
Yes,
ma'am.
ma'am.
Okay. Just all of you check. Did you get 640 mg per dm cube? Everyone got the same answer? Okay. So take down the next question now. 25 ml of sewage water was mixed with 25 ml of potassium dichromate, acidified and refluxed. The unused potassium dichromate required 8.2 ml of FAS. In a blank titration, 25 ml of potassium dichromate required 16.4 ml of same 0.2 N FAS. Calculate the COD of the sample. So, water sample volume taken was 25 ml. So, volume of the sample taken, whether it is sewage water or the distilled water, we have to take the same volume. So, that volume is 25 ml. So, volume of the sample taken V is equal to 25 ml, and on titrating we got back titration value as 8.2 ml of FAS, and blank titration we got as 16.4 ml. For blank titration, burette reading is 16.4 ml and concentration of FAS is 0.2 N. So calculate the COD and let me know the answer.
Ma'am, 524.8.
Correct. 524.8. Has everyone got the same answer? 524.8 mg per dm cube.
Yes, ma'am.
Okay. So next question is, so you see this kind of numerical. So you can see it's 20 cm cube of industrial effluent sample required 8.5 cm cube of 0.05 N potassium dichromate. Calculate the COD of the effluent sample. So only this much data will be given here. So they have not given how much burette reading came for blank titration, how much burette reading came for back titration using FAS, and what is the concentration of FAS. So nothing is given. So actually it is having such a lengthy calculation. It is quite confusing. So for this kind of numericals, I have found an alternative method in some of the textbooks, and we will solve this kind of numericals using the other method rather than this method. Okay, so till now, this numerical was not asked in your video semester end examinations, but just last semester, this numerical was asked. Until then, it was not asked. Until then, the previous questions which we solved till now, right? Only those type of questions were asked. But just previous semester, even this kind of numericals were asked. Okay, so in the maths has seen 5 to 6 marks. So note down the question. So this is the simple way of calculating COD just by using the normality equation and the COD formula. Okay, so here see 20 cm cube of an industrial effluent sample required 8.5 cm cube of 0.05 N potassium dichromate. Calculate the COD of the effluent sample. Only this much data is given. So what they are saying, volume of the sample taken was 20, and to oxidize the organic matter present in that effluent sewage water sample, 8.5 cm cube of potassium dichromate was used, and potassium dichromate concentration was 0.05 N. Only this much data is there. Okay, so nothing related to FAS, nothing related to blank titration, nothing related to back titration, nothing with respect to the concentration of FAS or the burette readings is being given. At such condition, what you do, just use the normality equation. N1V1 is equal to N2V2. So N1V1 let it be for the effluent sample and N2V2 let it be for the potassium dichromate. So potassium dichromate normality is 0.05. Volume of potassium dichromate consumed for the oxidation of the organic matter in the effluent sample was 8.5 ml, and the volume of the effluent sample taken was 20 cm cube. So when we calculate this, we get the normality of the effluent sample as 0.02125 N. So using this value, let us find the COD. So COD is equal to whatever the normality you got for the effluent sample, take that, multiply it by 8, 8 by 8, equivalent weight of oxygen, right? As we are studying this with respect to the oxygen demand, amount of oxygen required for the oxidation of the organic materials present in the effluent sample. So it is with respect to oxygen, so multiply it by 8, which is the equivalent mass of oxygen, and multiply it by 1000 as the unit is in terms of mg per liter. So take this answer, multiply it by 8000, you will get the final answer, that is the COD of the effluent sample. Okay, so here also, please make sure that you write in detail N1 is what, V1 is what, N2 is what, V2 is what, and then you write the formulas. Never forget to write the formulas and then do the calculation with substitution and also with the units. Okay, clear? This numerical is clear?
Yes, ma'am.
So, shall we go for the next one?
Yes, ma'am.
Okay, take down the numerical. Calculate the COD of the effluent sample when 25 cm cube of the effluent requires 8.9 cm cube of 0.01 m potassium dichromate for complete oxidation. Here, volume of the sample taken was 25, and to oxidize the organic impurities, 8.9 cm cube of potassium dichromate was used. It was consumed, and the concentration of potassium dichromate is 0.01 m. Molar concentration is given here. And in this case, M1V1 is equal to M2V2 molarity equation is not going to work. Okay, so instead what we'll do, we'll convert this molarity into normality. You know, right? Normality is equal to molarity into N factor. So let us use that, and again we'll follow the same method as we used for the previous numerical. So N1V1 is equal to N2V2. N1V1 is for effluent and N2V2 is for potassium dichromate. But potassium dichromate is given in terms of molarity, so convert it into normality, and normality is equal to molarity into N factor. So what is N factor for potassium dichromate? Potassium dichromate is involved in here. The reaction which we are carrying out is the redox reaction, right? So for the redox reaction, N factor is nothing but the total number of the electrons gained or lost during the reaction. We can just see this. So for potassium dichromate, I've just written the reaction. Change in the oxidation state is from +6 to +3, right? So potassium dichromate is going to oxidize others and reduces itself. Say for example, if we have FAS here, it is going to oxidize FAS from +2 to +3 and itself will get reduced from +6 to +3. It will oxidize Fe +2 to Fe +3 and itself will get reduced from +6 to +3. So here, once we balance the equation, here we have 2 chromium, here we have 2 chromium, and here we have 12 plus 12, and here we have +6 now. So in order to balance this reaction, we need to add 6 electrons here. So the number of electrons involved in this reaction is 6. Therefore, N factor is 6. And as in case of COD, we are using potassium dichromate as an oxidizing agent. So do remember that for potassium dichromate, N factor is 6. So multiply it with the molarity 0.01. You will get the normality as 0.06 N. Now substitute it in this formula. N1V1 is equal to N2V2. And let me know how much you will get the COD.
Ma'am, 170.88.
1 second. Yes, correct. It is 170.88. So substitute the value of the normality of the potassium dichromate which we got, and the volume of the potassium dichromate consumed is 8.9 cc, and the volume of the sample taken was 25. So you'll get the normality of effluent. So this value, multiply it by 8 into 8,000, you'll get 170.88 mg per liter. Did everyone understand this? This has to be done only if molarity is given. If normality is given, direct. Did you all understand?
Yes, ma'am.
Only one answer?
Yes, ma'am.
Okay. So take down the last numerical. 25 ml of an industrial effluent sample consumed 5 cm cube of 0.5 N potassium dichromate solution for the oxidation. Calculate COD of the sample, effluent sample. So here directly potassium dichromate is given in terms of normality. So use the normality equation and then do the COD calculation.
Ma'am, 800.
Correct. 800 is correct. All of you check. You have to get 800. Did you all get 800? Others?
Yes, ma'am.
Okay. So did you all understand the form how to calculate COD? If this kind
Yes,
of
ma'am.
numericals are asked, use normality equation and do the COD calculation. If burette readings are given, then use that actual COD formula B minus A into normality into 8000 divided by volume. Okay.